This video is going to teach how to solve a system of equations using substitution. So recall, a system of equations is a set of two equations with two unknowns. In this case, we're talking about a linear system of equations, meaning that the variables x and y are to the first power. So let's teach the method of substitution, and the method of elimination is a separate video. So for that one, you're going to need to use elimination. In this one, we're going to use substitution. So what are the steps? So step one, we're going to pick an equation and solve for one variable in terms of the other. And just as a hint, try to avoid fractions. You'll see what that means in a moment, but the rough idea behind this is you don't want to pick a variable so that if you solve for it, you end up with fractions, because that leads to more difficult problem, leads to more work. Okay, step two. Substitute this expression into your other equation for the solved variable. So what does that mean? That means that if you solve for y in the first equation, you're going to replace the expression with y in the second equation. So just substitute the expression into the other equation. Also very important that you choose the other equation, not the equation that you just used. Very, very important. Okay, step three, simplify. Step four, solve the equation. Now, you're going to get a solution except for the times that the variables disappear. Now remember, sometimes you have an exception. So here's going to be my little exception. If your variables all disappear, then you either have left a true statement or you have left a false statement. Recall, if it's a true statement, such as 1 equals 1 or something like that, then you're going to write infinitely many solutions. If it's a false statement, like 0 equals 2, then you're going to write no solution. Now, almost always, that's not going to happen. So once you solve the equation, you're going to substitute the solution into any equation to find the other variable. So that's basically it. There are 5 steps. Let's go ahead and do an example problem. So problem 1. Solve. So for all these, we're going to solve using substitution. So we have y equals 4x minus 1 and 6x minus 5y equals negative 2. 6x minus 5y equals negative 2. So, step 1, pick an equation and solve for one variable in terms of the other. Notice in this problem that we already have one variable by itself. The y here is already by itself. That means that step 1 is already done for us. So let's go on to step 2. It says substitute this expression into the other equation. So what I'm going to do is I'm going to take this expression for y and I'm going to substitute that in to the second equation instead of y. So I end up with 6x minus 5 times y equals negative 2. From here I simplify, so distribute that. I get 6x minus 5 times 4x plus 5 times 1, or 6x minus 20x plus 5 equals negative 2. And combine my like terms, I get negative 14x plus 5 equals negative 2. Now I solve for the variable that's left, so I subtract 5. I get negative 14x equals negative 7. Divide both sides by negative 14. I end up with x equals 1/2. So x equals 1/2. So what do I do once I get my answer? Well, it says substitute it into any equation to find the other variable. So why don't I plug it into the top equation, since that already has a y by itself. So if I put it in here, I get y equals 4 times 1/2 minus 1. Remember, that's like a 4 over 1. So if I multiply, this ends up being 2. So y equals 2 minus 1, which is 1. So my answer is x equals 1/2, y equals 1. Or another way of writing that is xy equals 1/2, 1. You can actually write your answer either of these ways. You can write it as a point, 1/2, 1, or you can just write it as x equals 1/2, y equals 1. Either way is okay. Now, just because this is the first problem that we did, I want us to check our solution. So, to check, we're going to plug both of these points into both equations to see if they both work. So, first, equation 1. We're going to put it in. We get 1 equals 4 times 1/2 minus 1. So is this true? 1 equals 2 minus 1, or 1 equals 1. So that works. Now we're going to try it in equation 2. Remember, equation 2 is 6x minus 5y equals negative 2. I get 6 times 1/2 minus 5 times 1 equals negative 2. So is that true? Well, 6 times 1/2 is 3 minus 5. So it checks. So this is what you should do when you're working on an exam and you want to make sure that you got the right answer. I highly recommend that you check your answers. Okay, let's do some more examples. So number 2. I want us to solve the following system. X plus 3y equals 5 and negative 2x plus 5y equals 23. Now it says pick an equation and solve for one variable in terms of the other. So I don't already have a variable by itself, so in this problem step 1 is not done for me. But notice the easiest variable to solve for is this variable right here because there's no number next to it. In other words, all I'm going to have to do is subtract. And that's great because I'm going to avoid using fractions. So I have x plus 3y equals 5. Subtract x from both sides. I get 3y. Sorry. My mistake. We want to move the 3y over. We end up with x equals 5 minus 3y. Sorry about that. So once I get my x, I take this, and this is of course step 2. I'm going to substitute this in to the other equation instead of x. So I get negative 2 times 5 minus 3y plus 5y equals 23. I simplify, I get negative 10 plus 6y plus 5y equals 23. Or combine my like terms, I get negative 10 plus 11y equals 23. Add 10 to both sides. I get 11y equals 33. Divide by 11, I get y equals 3. Now once I get my y equals 3, I plug it into either of the top equations. Actually, it's easiest to plug it into this one. I get x equals 5 minus 3 times 3, or x equals 5 minus 9, or x equals negative 4. So my answers are x equals negative 4, y equals 3, or I can write it as the point negative 4, 3. Either way is fine. Okay, so let's work on the next problem. This is going to be a tricky one. So number 3, I have 1/12 x plus 1/4 y equals 3/2, and 2/5 x minus 1/2 y equals negative 3. Now notice I have fractions. So the first thing I'm going to do is actually eliminate the fractions. And let's remember how to do that. We can actually get rid of fractions by multiplying by the LCD. So multiply by the LCD in each fraction, in each equation, to clear all the fractions. So in the first equation, I have LCD of 12. In the second equation, I have LCD of 10. So let's go ahead and multiply equation 1 by 12. So I'm going to do this equation by 12 and this equation by 10. If I do the first equation by 12, I'm going to go ahead and distribute the 12 to all the terms. Second equation by 10. What do I end up with? Well, in the first one, the 12s cancel. I'm just left with x plus. In the second one, the 4 cancels. I'm left with 3 times 1y, so 3y. And I end up here with 6 times 3 is 18. In the second one, the 5 cancels with the 10. I'm left with 2 times 2x is 4x. Here the 2 cancels with the 10. I'm left with minus 5y. And then I have negative 30. So I've gotten rid of my fractions, and now I can do the problem. This will work a lot better. Once your fractions are gone, then your problem becomes a lot easier and cleaner. So I'm going to solve for one variable in terms of the other. This variable is the easiest one to isolate. So if I subtract 3y from both sides, I actually end up with x equals 18 minus 3y. I'm going to take that and substitute it for x right here. I end up with 4 times 18 minus 3y minus 5y equals negative 30. Distribute the 4, I get 72 minus 12y minus 5y equals negative 30. Combine my like terms, I get 72 minus 17y equals negative 30. Finish up by solving for y. I'm going to subtract 72 from both sides. Negative 30 minus 72 is negative 102. Let me go ahead and rewrite it up here. So if I divide both sides by negative 17, I actually end up with positive 6. Positive 6. Substitute that into this equation right here. I end up with x equals 18 minus 3 times 6, or 18 minus 18, which is 0. So I get x equals 0, y equals 6, or another way to write that is the point 0, 6. Okay, we've done a lot of different examples. Let me show you some special cases. So I want us to solve the following system of equations. It's going to be 2x plus y equals negative 3, and 6x plus 3y equals 0. So first we're going to solve for one variable in terms of the other. Notice that this is the easiest one. So we get y equals, if I subtract 2x from both sides, I end up with y equals negative 2x minus 3. So I'm going to take this and I'm going to substitute it in for y right there. So I get 6x plus 3 times y equals 0. Distribute my 3, I get 6x minus 9 equals 0. Combine my like terms and I get negative 9 equals 0. But wait a minute, notice that something happened. All of my variables disappeared. Remember what that means. When you left with something false and all your variables disappeared, then that means you have no solution. Okay, so actually, if all your variables disappear, you shouldn't panic. That actually means you're done with the problem. Okay, so it actually is a lot easier if this happens. Okay, let's try another one. We're going to solve the following system. X equals 12 minus 2y, and 2x plus 4y equals 24. First, notice that I've already got x by myself. Right? I'm going to put that in for x in the other equation. I get 2 times 12 minus 2y plus 4y equals 24. Distribute this, I get 24 minus 4y plus 4y equals 24. Combine my like terms, I get 24 equals 24. So notice that all the variables disappeared again, and we're left with a true statement. This implies that we have infinitely many solutions. Infinitely many solutions. In particular, what this actually means is that this line and this line are the same line. Since they're the same line, they actually have an infinite number of solutions since they intersect everywhere. There you have it. These are all the different examples I wanted to do. So good luck working on systems of equations, and I hope to see you guys next time.